MSc Part 1, Paper 3 Organic Chemistry, in that Unit 4 NMR Spectroscopy and Mass Spectroscopy. Next new point is carbon 13 NMR spectroscopy, is C13 NMR spectroscopy. The proton NMR H1 NMR spectroscopy gives the following information about the structure of organic compound. Firstly is the number of principal signals can be often used to know the number of type of protons. Then chemical shifts provide the clue of a chemical environments of the type of the protons. Then relative areas under the signals are proportional to the number of protons give the rise to the signals. Then the splitting pattern provide the information about the neighboring protons. So these features are clearly observed, for example, in the H1 NMR spectrum of ethyl phenyl acetate. In the comparison of two H1 NMR spectroscopy, the C13 NMR spectra are more easily interpreted and gives the following information. So the first is the common range of energy absorption for C13 wide is a delta 0 to 200 relative to TMS, means concerted with the delta 0 to 15 for the H1 NMR, and thus fewer peaks overlap in the C13 spectra. So the because only the 1.1% of a carbon in the compound is a C13 is a C13 coupling in the neighboring and thus they is not observed. Therefore, in the one type of the C13 NMR spectra, proton decoupled is magnetically non-equivalent carbon gives the signal unsplit peak. So the presence of a plane of symmetry in the organic molecule under the some carbon chemically equivalent to others, and this may be lead to the disparity between the apparent number of peaks and the actual number of carbon atoms and present in the molecule. And in ethyl 2-phenyl ethanoate there are the 10 carbon atoms, but the plane of symmetry renders in the C2 to C13 C2 is equal to C6 and C3 is equal to C5, and so only 8 peaks are observed in the broadband decoupled spectrum of this compound. And the areas under the peaks in a C13 NMR spectra are not easily proportional to the number of carbon giving the rise to the signal, and therefore one does not consider the area reaction. In the proton coupled spectra, the signals for each carbon or group of the magnetically equivalent carbons is split by the protons bonded directly to the carbon and n+1 role in followed. These features are again observed in C13 NMR spectrum ethyl phenyl acetate. So the some carbon NMR utilize an isotope in a low nature abundance is the C13. Carbon C13 NMR spectra are much more difficult to record than an H1 NMR spectra. This is due to the two reasons. Firstly is the most abundant isotope of the carbon C12 is 99% and is not detectable by nuclear magnetic resonance, and this is so the since this isotope has an even number of the protons and an even number of neutrons and no magnetic spin. The less abundant is the isotope is a C13 has an odd number of neutrons and gives the it one magnetic spin is of 1/2 means half, just like the proton. And secondly, the magnetic resonance of a C13 is much weaker, and thus due to the only 1% of the carbon atom in the sample being a magnetic isotope, and the sensitivity of a C13 NMR is the decreases by the factor of 100, and moreover due to the gravimetric ratio of C13 being only 1/4 that of proton, and so the C13 resonance frequently is only the 1/4 factors is a C13 NMR is a less sensitive than the H1 NMR, and therefore the for the in a computer and the fairly computer is then used as average the stored spectra and the accumulated spectrum it is self to plotted by the computer in symmetry. Hundreds of spectra are normally averaged to give a assembled spectrum in which the single are reinforced. So the next point is the C13 spectrum and general study. In advantages of the low abundance of a C13 in absence of the carbon-carbon coupling, some point is noted. The firstly is that just like hydrogen, two adjacent carbon, if the magnetically non-equivalents, the coupling can occur only if the two C13 isotope come to the lie next to each other, and due to the abundance of the C13 in the molecule at 1.11%, if the situation has a very low probability. The most C13 nuclei are surrounded by the only C12 nuclei, which having no spin do not give the rise to spin-spin splitting. Consequently, the C13 NMR spectra are appreciably simplified, reducing the problem on the analysis to the determine of the coupling pattern to any attached hydrogen. So the C13 spectrum of ethyl phenyl acetate shows these the features. The chemical shift of the delta is defined as in H1 NMR and determine the relative to the internal standard, normally the carbon absorption in TMS. So the chemical shift range of the carbon is much larger than the that of the hydrogen. The most aromatic compound is covers the distance of about the 200 ppm in the constants with the relatively narrow spatial windows of a hydrogen. While the splitting of useful in the study of a simple molecule in several situations, however, it makes the spectrum of a more difficult to interpret it. For this reason, the two to increase the signal strength of a CMR spectra and normally recorded under the condition in which the protons are decoupled from the carbon. The moreover, the effect of a substitution in C13 shift is not conformed into to the nearest atom, so as in the proton chemical shift, but the effect of a substitute in the 2, 3 or 4 carbon and the carbon atom moves chemically shift under the study must be the evaluated. Thus, the 1 pentanol in its proton decoupled C13 NMR spectrum shows the separate peak for each carbon. This situation may be compared with the peak for each carbon. So H1 NMR spectrum are related to the compound 1-hexanol, and where the central methyl group are overlapped to give only one broad signal between the delta 1.2 to 1.8, and it is under the special condition that protons of the each methylene group of spread out. So there is a N-pentenyl alcohol. The 1:1:1 triplet is near to the delta is equal to 76 is due to the carbon of the CDCl3 and the solvent of deuterium to H has a 3 spin state -1 0 +1, and there is a force of the split is coupled resonance into the 1:1:1 means triplet. Moreover, one may be noted that the chemical shift in C13 NMR are much greater than the in H1 NMR spectra. In this example, these courage from the delta 14.1 to the delta 62.1. Thank you.